Hello everyone, I am Simran Kaur, your science teacher from Shiv Jyoti Educational Group, and welcome back to part 2 of chapter 13, Motion and Time. In first part of the video, we discussed that what is motion, what is slow and fast motion, speed and measurement of time. Now in this part, we will discuss about how to measure speed, average speed, about uniform and non-uniform motion and distance time graph. Speed, in the previous video, I told you that what is speed? The distance covered by an object in a unit time. Formula for speed is equal to distance upon time, that how much distance that object is travelling in a unit time. Can you tell me the unit for distance? It is measured in meters, kilometers, and time in second and hour. So, the SI unit of speed is meter per second. SI unit of distance is meter and for time it is second. So, SI unit of speed is meter per second and we represent it by like this m and m upon s or m s raised to power minus 1. Let us do a question. A school bus covers a distance of 9,000 meter in 1500 seconds. So, calculate its speed. For speed, we should know the distance travelled by an object and the time taken. So, distance travelled by bus is given 9,000 meter and time taken is 1500 seconds. So, put these values in this formula of speed. Instead of distance, we will write 9,000 meter and in place of time, we will write 1500 seconds. Now, just simplify it and what will be your answer? What will be your speed? 6 meter per second. Very simple. But now, it is difficult to represent large distances in meters and time in seconds. Like here we were taking the large distance 9,000 meter and time was 1500 seconds. So, it is a little bit complicated. So, instead of meter per second, we can use the larger units like kilometer per hour. Instead of meter, we are taking the bigger unit of distance, which is kilometer, and instead of second, we are taking the greater unit of time, which is hour. Now, we can convert meter per second to kilometer per hour and vice versa, means from kilometer per hour to meter per second. Let us see how we can convert it. In 1 kilometer, how many meters are there? 1000 meter. So, you can convert, if I give you an example of 10 kilometer. So, can you tell me that how many meters are present in 10 kilometer? What will you do? You will just simplify multiply 10 with 1000 meter and you will get 10,000 meter. So, there you were converting kilometer into meter. Here we are converting the unit of speed meter per second to kilometer per hour, means we are converting smaller unit into the larger unit of speed. How can we convert it? We can easily convert speed in meter per second to kilometer per hour by multiplying the term by fraction 18 upon 5. You just have to memorize this fraction 18 upon 5. Example will make it more clear to you. Here, what speed is given? 10 meter per second is given. The speed is given in meter per second. Now, I am asking you to convert it into kilometer per hour. So, what will you do? Just take this 10 and multiply it with the fraction 18 upon 5. Simplify it, you will get the answer 36, and which unit you will use now? This kilometer per hour. So, very easy to convert, multiplied by 18 upon 5. In opposite case, means when we have to convert kilometer per hour to meter per second, what will you do? You will multiply that speed with the fraction 5 upon 18, and in that case we were using 18 upon 5. In this case you can use 5 upon 18. Now I understand that it is little bit confusing that 18 upon 5 or 5 upon 18. So there is a trick which you can apply, like we are converting the larger unit into smaller unit. So here when we are going to smaller unit, we are taking smaller number in the numerator, whereas in that case we were converting the smaller unit into larger unit, the bigger unit. So here in the numerator we were taking the bigger number, the larger number 18. Okay. Again, take an example, you have to convert 18 km per hour to meter per second. You will multiply this 18 with what fraction? With 5 upon 18. Just simplify it and you will get 5 and unit will be meter per second. Very easy conversion. Now, average speed. Now, you know that what is speed. We will discuss what is average speed. Suppose you are driving and suddenly a dog or a child come in front of your car. So what will you do? You will crush it or you will apply brakes? Obviously you will apply brakes, you will slow down, and then again when they will cross your path, then you will again speed up and you will start moving. So in the whole scenario your speed was not constant, it was changing. So in that case we need to find average speed. No vehicle moves with constant speed, obviously. So therefore, to determine how fast a vehicle moves, average speed is calculated. And formula for average speed is total distance travelled upon total time taken. And in the normal formula of speed, we were taking simply distance upon time. Here we are taking total distance upon total time taken. Take an example, a runner covers 100 meter in 10 seconds and the remaining 100 meter in 8 seconds. You have to calculate speed for the first 100 meter and the second 100 meter, and also calculate the average speed of the whole journey. We have divided his whole journey into two parts. Initially he was covering 100 meter in 10 seconds and then he increases his speed and he covered 100 meter in only 8 seconds. Let's see. The speed of a runner in first 100 meter, speed formula for speed is distance upon time. Distance is given 100 meter, so put 100 instead of distance, and time given is 10 seconds. So instead of time just write 10. Divide it and you will get 10 meter per second, his speed in the first lap. The speed in next 100 meter is distance upon time. Distance is same 100 meter, but in case of time we will take now 8 seconds. Divide it and you will get 12.5 meter per second as his speed. Now we will calculate his average speed. Formula is total distance travelled divided by total time taken. Total distance is what? 100 meter and next 100 meters, means 100 plus 100 divided by total time is, initially he was taking 10 seconds and then 8 seconds. So add this up, 10 plus 8, you will get 200 divided by 18. Divide it and you will get 11.11 meter per second as his average speed. Understood? Now speed measuring devices. We use speedometer. You have seen it in all vehicles, in cars, bikes, scooties. This is speedometer. It tells us what? The speed of that vehicle. So it measures the speed in kilometer per hour. The unit here is kilometer per hour. We are taking the larger unit of speed. In this image, the speed of this vehicle is what? 0, means it is not moving. The speed is 0. It is at rest. Next device is odometer. It is an instrument used for measuring the distance travelled by a vehicle. Here you can see like the distance, the total distance covered by any vehicle is measured using odometer. Speedometer measures the speed, whereas odometer measures the distance travelled. Okay, the next and important topic is uniform and non-uniform motion. What do you mean by the word uniform? Same, equal, like you come to school in your school uniform. School uniform means in which you all look alike, you look same. In case of uniform motion, a body or an object is said to have uniform motion if it covers equal distances in equal interval of time. Look at this image. This is a car. It started from here, point O. In 2 seconds, it covered 4 meter. In again 2 seconds, it covered next 4 meter. Then again in next 2 seconds, it covered next 4 meter and so on. So this car is covering 4 meter in every 2 seconds, means it is covering equal distances in equal interval of time. So this car has what type of motion? This car is showing uniform motion. In case of non-uniform motion, the body covers unequal distances in equal interval of time. Here you can see the same car. In first 2 seconds, it covered 1 meter. Then in next 2 seconds, it covered 9 meters. Then in next 2 seconds, it covered 15 meters. So distance is not same in each interval. So when body covers unequal distances in equal interval of time, means this car possesses non-uniform motion. Now distance time graph. We have taken two axes, x and y axis. On x axis we take time and on y axis we take distance. So we plot a graph of the distance versus time for both uniform and non-uniform motion. Graph for non-uniform motion, we know that body covers equal distance in equal interval of time. So the graph will be a straight line. You can see in first minute it is covering 10 meters of distance. Then in next 1 minute it is covering again the next 10 meters and so on. So the graph will be a straight line. Whereas in case of non-uniform motion, body covers unequal distances in equal interval of time. So the graph will not be a straight line. Here you can see in first minute it is covering, let's say 7 meters. Then in first 2 minutes it is covering 7 meters. Then it suddenly speeds up and the line is not straight. So graph of non-uniform motion is not a straight line. Can you tell me this graph show what type of motion? It shows that the object is at rest. As you can see, time never stops, it keeps on going, but the distance we are getting a parallel line to time axis, means the body is at rest. It is not changing its distance or it is not covering any distance. So that was all about non-uniform and uniform motion and distance time graph. Thank you for watching.